Welcome to this explainer. Today, we're diving deep into the highly scientific machinery of modern agricultural water management. And, if you think farming is just about dropping some seeds in the ground and crossing your fingers for rain, well, prepare to have your perspective completely shifted. We're going to unpack the hidden architecture that literally keeps our global food supply alive. We call this becoming masters of the flow. So let's just jump right in, starting with a totally shocking statistic that fundamentally changes how we need to look at water distribution. Up to 40%. Let that sink in for a second. Up to 40% is the staggering amount of water lost strictly to seepage in traditional, unlined earth channels before a single drop even reaches the crop's root zones. Imagine paying for, pumping, and moving hundreds of gallons of precious water and losing nearly half of it on the journey. It's a massive economic and environmental hemorrhage. And for generations, traditional farming just accepted this as, a cost of doing business. But here's the thing, we absolutely cannot afford to operate that way anymore.
To actually stop this massive drain, we have to elevate our whole perspective. We really need to stop looking at a farm as just a flat plot of land and start treating it as what it really is, a complex biological factory. And what's the most critical component of any factory? The power source. The water distribution system is the primary critical engine of this biological factory. If that engine is leaking, the whole factory fails. It really is that simple. So we have to engineer this engine with the exact same precision we'd apply to a modern industrial facility.
So where does all this engineering actually begin? Well, it begins at the absolute front line with a concept known as the check or the block. Think of the check as your strategic local grid. It's the localized network where the massive macro water supply gets divided up among the individual farmers. This is where the rubber meets the road. It's where disciplined community management dictates whether a farm thrives or starves. Because if the check is mismanaged, that entire biological factory we just talked about, it grinds to a halt. Now, when you map out this spatial layout, you can see exactly how this vascular system operates in the real world. Water flows from the massive macro source, which is the command area, down into the check's primary delivery arteries. From there, it's carefully diverted into these tiny microcapillaries known as the Setha Nali, or field channels, which directly feed the plants. It is a beautiful, intricate, vascular system. But I'll tell you, maintaining the right pressure and flow through all those branches is a monumental challenge. Understanding this vast, interconnected network begs a really important engineering question for anyone working in agriculture. How do we physically construct these field channels so they efficiently deliver water while constantly fighting the destructive forces of gravity and soil erosion? Because let's be honest, water is inherently lazy. It just wants to sit still. But it's also incredibly heavy and abrasive. When it does move, it wants to tear down the very walls trying to contain it. The physical solution to that battle lies in precise cross-sectional geometry. We're moving far away from randomly dug dirt ditches and stepping into highly scientific trapezoidal construction. By utilizing extremely specific 45-degree side slopes and a 60-degree base angle, engineers found the perfect sweet spot. This specific geometry perfectly balances the downward pressure of the water with the lateral stability of the soil banks. It's elegant structural mathematics applied directly to the mud and dirt. And this brilliant design is really all about the physics of flow. It's about hitting what we call the Goldilocks zone on the activation curve. See, if a channel is too wide or rough, water velocity drops, which causes silt to settle and choke the whole system. But if it's too steep or narrow, the water moves way too fast and violently erodes the channel walls. This scientific trapezoidal design keeps the water velocity right in that perfect zone, fast enough to avoid siltation, but slow enough to prevent structural erosion. It's perfect flow. So the crucial point is seeing how this theory impacts the real world on a diagnostic matrix. When we map this scientific method against traditional practices, the contrast is absolutely undeniable. Remember that 40% loss? It drops to under 5%. Because the channels aren't constantly eroding or silting up, maintenance costs just plummet. But perhaps the most amazing part? The distribution speed becomes so fast and predictable that water pressure is finally equitable. The tail-end farmers at the very edge of the grid finally get the exact same resources as the guys right at the front of the line. It essentially presents a really clear choice for modern agriculture between two realities. On one side, you have the drain, characterized by immense seepage, massive evaporation, and the just grueling manual labor of constantly digging and rebuilding mud walls. On the other side, you have the save. This is achieved through strategic concrete lining, low-head piped distribution, and smart PVC turnouts that lock securely. It's the difference between constantly fighting your environment and actually mastering it. But as any good engineer will tell you, building these resilient arteries is only step one. You have to actively protect them using a rigorous diagnostic checklist. You've got to routinely inspect the intake gates to ensure those seals are completely watertight. You have to actually walk the channel body to identify and plug structural cracks or, and this is a big one, rodent burrows, which can destroy a bank from the inside out. And you must constantly clear silt from the outlets so outbound flow isn't restricted. This vigilant maintenance forms a vital protective shield against water loss, and to be effective, it really must follow a disciplined chronological cadence throughout the year. It starts with pre-season desilting and patching before the water even flows. Then it transitions to mid-season, where daily visual checks are totally required to catch any localized seepage immediately. Finally, it wraps up with a post-season structural assessment to reinforce the whole system for the following year. It's a continuous, unbreakable loop of care. And as we push this maintenance cycle into the future, the technology is evolving at breakneck speed. We're moving from analog guesswork and heavy manual wooden gates to incredible smart interventions. Just imagine upgrading your chot to utilize low-cost digital soil moisture sensors, weather-synced predictive irrigation planning, and automated solar microgates that actually open and close based on real-time data. I mean, this isn't science fiction anymore. This technology is here right now, and it's unlocking entirely new, unprecedented levels of efficiency. Now, you might be wondering, why does optimizing one single local grid matter so much in the grand scheme of things? It comes down to the true power of the network effect. Precise micro-actions within a single chalk, like plugging a leak or installing a smart gate, ripple outward. When hundreds of chalks operate efficiently, it creates a massive macro result: extended irrigation coverage for the whole region, stabilized underground water tables, and deeply rooted community-wide drought resilience. Your local fix literally saves the regional ecosystem. This continuous optimization fundamentally transforms farming from a game of chance into a highly profitable water wealth cycle. It's a four-step engine. Step 1, build smart with scientific channels. Step 2, stop leaks through rigorous maintenance. Step 3, distribute that saved water equitably across the grid. And step 4, harvest the wealth that comes from the resulting increased yields. And the absolute best part, that new wealth loops right back around to fund the next cycle of technological innovation. So how do you step into this water wealth cycle today? Well, you follow this immediate action plan for the upcoming season. Step 1, conduct the audit. Walk your field's channels this week and map every single leak and crack. Step 2, execute the 80-20 fix. Focus your immediate labor on fixing the 20% of severe leaks that are likely causing 80% of your water loss. And step 3, form the alliance. Convene with your local water committee, your Pani Panchayat, to schedule joint maintenance. You cannot do this alone. So I want to leave you with this final provocative thought to take back to your own operations. Upgrading to a scientifically managed chunk isn't just a matter of saving a few gallons of water or making your fields look a little tidier. It is the fundamental existential decision to master the flow of your most precious resource. Will you let your biological factory's engines slowly drain away into the dirt, or will you take control, eliminate the waste, and secure your community's future? The science is there, ready when you are. Thanks so much for joining me on this explainer, and I'll catch you in the next one.